Imagine this. It is a calm summer morning in the Yukon. Birds sing, rivers flow, and towns go about their day as usual. Suddenly, without warning, the ground begins to rip apart. Buildings sway violently, roads crack open, and in a matter of minutes, a catastrophic earthquake shakes everything from Alaska to the Canadian Northwest. Scientists warn that such a scenario is not only possible, but inevitable. They believe that deep beneath this seemingly stable landscape lies a powerful, hidden fault line capable of unleashing devastation across Canada and the northern United States. This is not a story of imagination. This is the story of the Tintina Fault. The Tintina Fault has been quietly storing energy for centuries, an energy that could be released in a single massive earthquake. Experts compare its potential to that of California's San Andreas Fault, but with a terrifying twist. Unlike the San Andreas, which is constantly monitored and well known, the Tintina Fault is a silent giant, largely overlooked by the public and even underfunded in terms of research. Today, we dive into what makes the Tintina Fault so dangerous, the science behind its growing threat, the history that warns us, and what could happen if it ruptures. By the end, you will understand why scientists are sounding alarms and why preparedness may be our only shield against disaster. What is the Tintina Fault? Stretching for an astonishing 1,200 kilometers, the Tintina Fault runs across the remote wilderness of Yukon in Canada, cutting through to Alaska. This massive geological structure is classified as a strike-slip fault, meaning that the Earth's plates slide past one another horizontally. These faults are notorious for producing some of the most destructive earthquakes in history, and the Tintina is no exception. For decades, geologists have studied its structure, finding evidence of immense tectonic stress building silently beneath the surface. The Tintina Fault is not just long, it is strategically dangerous. It lies in a region where human settlement is growing, where vital trade routes and pipelines pass, and where natural resources fuel the economy. Its movements are subtle, often going unnoticed, yet capable of sudden shifts that release incredible energy. To put this into perspective, scientists often compare it to the San Andreas Fault in California. The San Andreas is famous for its frequent tremors and strict monitoring systems, while the Tintina has remained in the shadows. This lack of frequent earthquakes has led many to believe it is less active, but the truth is far more unsettling. Long periods of silence on a fault line do not mean safety. They often mean strain is accumulating, waiting for a violent release. Because of this deceptive calm, the Tintina Fault is known as a silent giant. It hides beneath vast forests and mountain ranges, far from the headlines, yet it holds the power to reshape landscapes and disrupt lives. Scientists caution that its next major movement could rival some of the largest earthquakes ever recorded in North America. The question is not whether it will move again, but when. History of earthquakes on the Tintina Fault. The recorded history of earthquakes along the Tintina Fault is surprisingly sparse, and this scarcity of data adds to its mystery. In modern seismic records, there have been very few significant events, which initially led some experts to downplay its threat. However, when geologists began digging deeper, literally, they found evidence that tells a much darker story. Studies of ancient rock layers and offset riverbeds reveal that the fault has experienced enormous earthquakes in the distant past. These quakes were powerful enough to shift entire landscapes, leaving behind scars that are still visible today. Geological surveys have uncovered zones where rock formations are displaced by tens of meters, a clear sign of intense seismic activity over thousands of years. Indigenous oral histories also provide valuable clues. The First Nations of the Yukon region have passed down stories of the land shaking violently, rivers changing course, and mountains crumbling. These accounts, though not recorded in scientific journals, align with geological evidence of major seismic events long before modern instruments existed. The lack of large earthquakes in the last few hundred years has lulled many into a false sense of security. Unlike California, where frequent tremors remind people of the danger, the Tintina Fault has remained eerily quiet. Scientists warn that this quiet is not a sign of stability. Instead, it likely means that stress is accumulating along the fault line, increasing the likelihood that the next rupture could be catastrophic. One of the most compelling pieces of evidence comes from shifted river valleys and torn sediment layers found along the fault's path. These natural records act like time capsules, showing that massive earthquakes have occurred here before. Each time, the land tore open with enormous force, and each time, it took centuries before the next great rupture. This long cycle of destruction and dormancy makes the Tintina Fault particularly dangerous. The absence of recent quakes means people are unprepared, infrastructure is not reinforced, and emergency plans are minimal. Meanwhile, the ground beneath remains restless. Scientists believe the fault is overdue for its next significant movement, and when that moment comes, it could release energy that has been building for centuries, shaking both Canada and the northern United States in ways we have not seen in modern times. Why scientists are concerned now? In recent years, scientists have turned their attention back to the Tintina Fault with a growing sense of urgency. What they have found is alarming. New research shows that strain is steadily building deep within the Earth's crust along this fault line. Using advanced technology such as LiDAR scanning and satellite GPS measurements, researchers have detected subtle but consistent ground movements in regions once thought to be stable. These small shifts may seem insignificant, but in the world of seismology, they are clear indicators of accumulating tectonic stress. Seismologists warn that the energy trapped within the Tintina Fault is reaching a critical level. According to recent assessments, the probability of a major earthquake, possibly exceeding magnitude 7, within the coming decades is far higher than previously believed. This projection has sparked concern among geologists from the Geological Survey of Canada and the United States Geological Survey, who have issued statements emphasizing that the risk is real and growing. They caution that while the fault has been quiet, this very quietness is what makes it so dangerous. What troubles experts further is the lack of public awareness and preparedness. Unlike regions that have experienced frequent seismic events, the Yukon and northern British Columbia have not invested heavily in earthquake readiness. Some researchers even believe the risk has been underestimated, arguing that the Tintina Fault has characteristics similar to other faults that produced massive quakes without warning. This scientific debate highlights a dangerous gap between what is known and what is being done to prepare. Controversy surrounds just how devastating the next event could be. Some scientists propose that the energy could release gradually, resulting in moderate quakes spread over time. Others fear a single, violent rupture that could rival the largest earthquakes in Canadian history. With new data revealing strain building along multiple segments, the stakes have never been higher. The Tintina Fault is no longer just a distant geological curiosity, it is a sleeping monster whose awakening could be catastrophic for both Canada and the northern United States. Potential impact of a massive Tintina Fault earthquake. If the Tintina Fault ruptures in a single massive event, scientists predict it could unleash an earthquake with a magnitude of 7.5 to possibly over 8. An earthquake of this scale would shake the very core of northern Canada and Alaska. The initial shockwaves would ripple through the Yukon, northern British Columbia, and parts of Alaska, with tremors likely felt across the northern United States. Entire towns could be leveled in seconds, and critical infrastructure could fail under the intense shaking. The physical destruction would not be limited to collapsed buildings. Landslides could devastate mountain roads and cut off remote communities. Rivers might change course, bridges could collapse, and the stability of hydroelectric dams could be threatened. If the rupture connects with offshore faults or triggers underwater landslides, the risk of localized tsunamis in river valleys and coastal areas cannot be ruled out. The cascading effects of such an event would be profound. Economically, the damage could soar into the billions. Oil and gas pipelines running through this region would be at risk of rupture, leading to environmental disasters and severe disruptions in energy supplies. Transportation corridors critical for trade could be severed for months, and rebuilding efforts would strain both local and national economies. The experience of the 1964 Alaska earthquake, which registered a magnitude 9.2 and caused widespread destruction, serves as a grim reminder of how vulnerable this part of the world can be. The human cost would be staggering. Casualties from collapsing structures, fires, and landslides would climb rapidly in the first hours. Thousands could be displaced, forced to seek shelter as aftershocks continue to rock the region for weeks. Emergency services, already limited in remote areas, would be overwhelmed. The social disruption caused by such an earthquake could last years, reshaping communities and leaving deep psychological scars. Comparisons to historic quakes like the 1906 San Francisco earthquake and the 1964 Alaska event show that large earthquakes not only destroy cities but also alter entire societies. In the case of the Tintina Fault, the combination of remoteness, underpreparedness, and infrastructure vulnerabilities make its potential impact even more concerning. The next major event could redefine what Canadians and Americans know about seismic risk in the north. Case studies of similar faults to understand what might happen if the Tintina Fault ruptures, scientists look to similar faults around the world. The San Andreas Fault in California is perhaps the most famous. It has produced numerous destructive earthquakes, including the 1906 quake that devastated San Francisco. The lessons from California are clear: strict building codes, early warning systems, and constant public education save lives. Even so, experts agree that when a fault releases energy on this scale, no amount of preparation can fully prevent destruction. Another important comparison is the Denali Fault in Alaska, which ruptured in 2002 with a magnitude of 7.9. That earthquake caused significant structural damage to roads, bridges, and pipelines, even in sparsely populated areas. The shaking was so intense that the Alaska oil pipeline shifted over 30 feet in some sections. Fortunately, it did not rupture, but the event served as a powerful warning of how fragile critical infrastructure can be in the face of seismic forces. The Denali quake also triggered landslides and aftershocks that continued for months, a scenario eerily similar to what could unfold along the Tintina Fault. The North Anatolian Fault in Turkey offers yet another sobering case study. In 1999, a magnitude 7.6 earthquake struck near the city of Izmit, killing over 17,000 people and leaving 500,000 homeless. Urban vulnerability and inadequate building standards turned what might have been a manageable disaster into a national tragedy. This example highlights how underestimating seismic risks can have catastrophic consequences when a large quake strikes an unprepared region. These case studies provide more than just historical lessons. They serve as mirrors reflecting what could happen in Canada's north. The Tintina Fault shares characteristics with each of these faults: long periods of silence, potential for high-magnitude events, and proximity to infrastructure that is not fully earthquake-resistant. Like the San Andreas, it runs through a complex tectonic environment. Like Denali, it cuts through remote areas where emergency response is difficult. And like the North Anatolian, it poses a deadly threat to communities that may not be ready when the ground finally gives way. The science behind the threat. To understand why the Tintina Fault is so dangerous, it is essential to grasp the science behind fault lines. Faults act like giant pressure valves deep within the Earth's crust. As tectonic plates slowly grind past one another, they accumulate stress along these fractures. This strain builds up quietly over decades or centuries until the rock can no longer hold, releasing its energy in a violent earthquake. The longer a fault remains locked and quiet, the more energy it stores, which is why scientists view the Tintina Fault's prolonged silence with growing concern. Canada's seismicity is often underestimated because the country is far from the edges of the Pacific Ring of Fire. However, the Tintina Fault is part of a complex system of crustal weaknesses influenced by plate movements across the North American and Pacific boundaries. This tectonic environment allows significant stress to build up over time, even far from the oceanic edges. What makes the situation more alarming is the possibility of a cascading failure. Scientists warn that a rupture along the Tintina Fault might trigger movement on adjacent faults, multiplying the destructive power of a single quake. In some scenarios, multiple fault segments could break in sequence, releasing an extraordinary amount of energy. This interconnected risk explains why experts are pushing for more monitoring, because a fault this quiet is not necessarily safe. In fact, it may be storing up for one of the most significant seismic events in North American history. Preparedness and current mitigation efforts. When it comes to earthquake preparedness, Canada and the United States have taken steps, but experts argue it is not enough for the scale of the threat. The Yukon, where much of the Tintina Fault lies, has limited seismic infrastructure and only basic early warning systems. Unlike California, which regularly conducts earthquake drills and enforces strict building codes, northern Canada remains underprepared. Many structures in the Yukon were not designed to withstand powerful seismic shaking, leaving communities vulnerable. The United States, particularly Alaska, has better seismic monitoring, but its focus has traditionally been on the Denali Fault and coastal zones, leaving the Tintina region with fewer resources. Public awareness campaigns are minimal, meaning residents are often unaware of what to do in the event of a major quake. Experts recommend urgent improvements. These include strengthening building codes, expanding seismic networks, and introducing community drills similar to those conducted in earthquake-prone Japan. Japan's success in minimizing casualties during major quakes comes from decades of investment in technology, education, and infrastructure reinforcement. In contrast, Canada's northern regions have yet to adopt such comprehensive measures. The gap in preparedness is troubling because once the Tintina Fault ruptures, there will be no time to react. Early warning systems may provide seconds of notice, but survival depends on having resilient infrastructure and an informed public long before the shaking starts. Without immediate action, the damage could be far worse than it needs to be. Controversies and debate. The Tintina Fault has sparked heated debates among scientists, policymakers, and industry leaders. Some seismologists believe that the risk is overstated, pointing to the lack of recent major earthquakes as evidence that the fault is relatively stable. They argue that scare tactics might divert funding from other pressing concerns. On the other hand, a growing number of experts insist that this quiet period is precisely why the danger is so high, warning that a catastrophic event is not a matter of speculation but of time. Political and economic implications further complicate the issue. Publicly admitting the scale of the threat could force costly upgrades to pipelines, trade routes, and energy infrastructure, placing financial strain on governments and corporations. Oil and gas pipelines crossing seismic zones in the Yukon are particularly controversial. Critics warn that a rupture could lead to environmental disasters, while industry advocates downplay the likelihood of such an event to avoid regulatory changes. Underfunding is another critical concern. Seismic monitoring stations in the Yukon are sparse, limiting scientists' ability to detect subtle ground movements that could provide early warning. This lack of investment creates a dangerous knowledge gap at a time when understanding the fault's behavior is crucial. These conflicting views leave policymakers in a difficult position. Should they spend millions preparing for a disaster that may not happen for decades, or risk being caught unprepared when the ground finally breaks? The debate rages on, but the fault continues to store energy regardless of human politics. Whether underestimated or overhyped, the Tintina Fault remains a sleeping threat capable of changing the course of life in northern North America. The Tintina Fault is more than a geological curiosity. It is a massive earthquake disaster threat to the US and Canada. It runs silently through remote wilderness, storing unimaginable energy that could one day erupt with devastating force. Scientists have uncovered the evidence, they have issued the warnings, and they continue to call for urgent preparedness. Yet for many, this danger remains out of sight and out of mind. The reality is unavoidable. The question is not if the Tintina Fault will rupture, but when. When that day comes, the impact will be felt far beyond the Yukon, shaking cities, disrupting economies, and altering lives across borders. We cannot afford to wait for tragedy to strike before taking action. Preparedness, awareness, and scientific investment are our best defenses. Stronger infrastructure, better monitoring, and public education can mean the difference between survival and catastrophe. The ground beneath us may seem stable, but it holds secrets that can change everything in seconds. The Tintina Fault is silent now, but one day it will speak. The only question that remains is whether we will be ready to listen before it is too late.